Greeting of the day everyone, my name is Akshat Bhargava and I will be presenting a presentation on the topic Waveguide Path for Radio Frequency Wave. I would like to thank my seminar guide Dr. S.S. Gudara sir for his continuous efforts and support throughout the journey. As designers, if we were asked a question that if we want to design a container which has the capacity of 10,000 liters of water, but the only catch was it should be made up of paper. It might be an impossible way or a possible way to do so, but definitely it will be an inefficient way to do so. Similar kind of problem was faced by the engineers when they were trying to find an alternative to transmission cables because of the high losses in their energy. Sir J.J. Thomson discovered a way, and it was called waveguides. A waveguide is a structure that guides RF waves. They are used just because of their minimal loss of energy, because they restrict the transmission of energy to one direction only. A simple definition about the waveguides is it is a hollow conductive metal pipe which is used to carry high frequency radio waves, particularly microwaves. Waveguides are divided on various parts, and we will be discussing about the rectangular waveguides, which is a classification made upon the type of cavity. On type of cavity, the waveguides can be classified on the basis of cross section, and it could be a rectangular waveguide or circular waveguide. So, how are waveguides named? The WR designation stands for the rectangular waveguides, similar to the figure which we are seeing right now. The number that follows WR is the width of the waveguide opening in inches. The waveguide width determines the lower cutoff frequency, and it is equal to half of the wavelength of lower cutoff frequency. So for example, if I'm talking about WR 75, so 75 is 0.75 of 1 inch, and if I'm talking about, then it will be 0.575 into 25.4 mm, which will be 19.05 mm. And the B direction which you're seeing in the figure will be 19.05 divided by 2, and it will be 9.525. What are the waveguides made of? A waveguide is typically composed of a metal with a low bulk resistivity. Why resistivity is being considered here? Just because the waves travel on the surface and resistance on the surface will be a consideration, such as brass, copper, silver, aluminum and silver can be used for as waveguide materials. Even if the inner walls are suitably coated, it is possible to employ metals with a weak conductive properties. And why metals? Even plastic waveguides can be created. What is it widely made of? Waveguide is generally made of aluminum alloy Al6061 T6. A question that might arise: what is T6? T6 refers to the temper or degree of hardness which is achieved by precipitation hardening. Why only aluminum Al6061? Surface finished and thermally coated aluminum waveguides show desirable mechanical properties. Here you can see the table which shows the mechanical properties of the alloy. It is easy to manufacture and affordable at the same time. Why plating is done on aluminum Al6061? The figure shows that silver plated waveguides are there. Being best conductor of electricity, silver is used for the plating in inner surfaces of waveguides. Why silver plating is done? As you can see in the figure, the sheet resistance of aluminum with so much less of thickness is very much high, and as we discussed, the resistance should be low if we are talking about the transmission of RF waves. Similarly, not an excellent way corrosion resistant and oxidation resistant surface the aluminum has. The best surface electrical conductivity silver is having, and it shows great RF performance. That's why silver plating is done on aluminum Al6061. But the fact is, once you are doing the silver plating on aluminum, you cannot directly do it. So that's why we need nickel plating on the surface of aluminum Al6061. Why? Because it provides excellent adhesion properties for subsequent coating layers, unique combination of corrosion and wear resistance. It increases the thickness of undersized surface, and it is also known as undercoat. Here a figure is shown on which nickel plating is done. Are waveguides always straight? The utility of waveguides go hand in hand with the volumetric space constraint. Therefore, waveguides are bended in order to solve both performance and space related problems. The waveguide bends and twists. What would happen if we twist or bend the waveguides? If we are twisting the waveguides, it will change the polarity of the fields. Whereas if we are bending the waveguides, it will change the direction of the fields. High frequency signals that are moving through a waveguide can be directed in a particular direction with the help of waveguide bends. Type of waveguides bend. It might be classified into two parts. It is E bend or H bend. An E bend changes or distorts the electric field, whereas the H band changes or distorts the magnetic field. The radius of the bends should be greater than two wavelengths of the signal. How are waveguides bended being hollow? It might be a good question that if we are bending a hollow thing, it might have wrinkles. So waveguides are bended using a material called Cerabond. Cerabond is a permanently elastic material with certain temperature ranges. It gets freezed in cross section, and after bending it, it is melted and removed. How are waveguides joined? Flanges are used to join the waveguides. Flanges are welded to each end of the waveguide before plating. Two waveguides with flanges are thus joined by the threaded joints. Waveguide applications. The applications are very much high. The bioimaging, medical diagnosis, communication, explosive detections, industrial inspections. Waveguides are used everywhere. Here a design of waveguide WR75 is shown. The collar design is shown. Assembly design is shown. The list of figures is being shown. The list of tables. References. Thank you so much.